Let's take a look at solving equations quadratic and form. This is also called the U substitution. So, solving equations using the U substitution. Now, step one, let the middle part be equal to U and the first part be equal to U squared. And let me get to, there we go. Okay. Now second part, or second step, solve for U. Step 3, replace U with the middle part from step 1 and solve for X. Changing my wording on that this time. Usually I say plug U equals blank back in and solve for X. Trying to see if this one will be a little bit more clearer on this step. We'll see. Okay, so we're going to follow these 3 steps on our problems. So let's take a look at our first one. And then we'll talk about the vagueness of each of those steps as we look at our first problem here. So I got x to the 4th minus 5x squared minus 36 equals 0. Now, where'd that 6 come from? Let me erase that. There we go. Now, if you're wondering, when can you use a U substitution? If you can take the middle part, whatever is right here, minus the coefficient number in front of it. So if I can take the middle part, which is x squared, raise it to the second power. And when we do that, that gives us x to the 4th. If it gives us whatever's here in the first, minus a number in front of it, the coefficient, that's when you can use a U substitution. I know that's pretty vague to say the middle part and the first part, but it really is that vague. It could be a term, could be a binomial, could be anything. So it's whatever's there. Well, first step. We're going to let the middle part here, this x squared, be equal to U, and we'll let this first part, this x to the 4th, be equal to U squared. Again, it never includes a number that's out in front. So we're going to rewrite this as U squared minus 5U minus 36 equal to 0. Second step, solve for U. Now, it's kind of vague there. Almost all the problems in this section will involve using the PSD method, but they don't have to. So that's why I left it kind of vague. There's different techniques you could use. You could use quadratic formula. But the goal here is to write it into a quadratic form. Okay. Well, I'm going to solve this using the PSD method. So this factors as U minus 9 times U plus 4 equal to 0. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So we'll set U minus 9 equal to 0, U plus 4 equal to 0, and then we'll solve it. So we get U is equal to 9, and U is equal to negative 4. Now step 3. It says replace U with the middle part from step 1. From step 1, we said the middle part was the x squared. So we're going to now replace the U with x squared. Basically, whatever you specify as U up here, which is always the middle part, would be what you plug in at this point for U. And then I'm vague again. I say solve for X. That's because there'll be various techniques you'll use at this point. This one, whenever you have something squared equal to something else, the square root property comes in handy. Square root property says if you got something squared equal to something else, you drop your squared, you put a plus or minus square root around the other side. Drop your squared, put a plus or minus square root around the other side. Now we want to simplify these. 9 is 3 times 3. And remember, with a square root, we're looking for a pair of something. So here's a pair of 3s, so they're going to come out as a single 3. And there's nothing left inside the radical, so it disappears. So we got x is equal to plus or minus 3. On this one, negative 4. We got negative 1 times 2 times 2. Now remember, square roots, we're looking for pairs of something. Here's a pair of 2s. A pair of 2 is going to come out as a single 2. And remember, a negative 1 inside of your square root comes out as an I. So this will be x is equal to plus or minus 2i. And those are our answers to this problem. Let's take a look at our second one. We got x plus 5 squared minus 3 times x plus 5 minus 28 equal to 0. Now this whole section is a U substitution, so we know we're going to do that. But you know, if I ran across this in a different circumstance, and I'm wondering, can I use a U substitution? Again, if you can take the middle part, ignoring the coefficient, the number in front of it. So if I take the middle part, which is x plus 5, raise it to the second power, and it gives you this first part. Well, obviously it does. After I put the second power on there, it's equal to it. That's when you can use the U substitution. So first step, let the middle part be equal to U and the first part be equal to U squared. So here's my middle part. This time it's a binomial. This will be U. Again, it never includes a number inside in front, the coefficient. And this first part's going to be our U squared. So we're going to rewrite this. This becomes U squared minus 3U minus 28 equal to 0. Now step 2 says solve for U. And again, we're going to use the PSD method here. And this factors as U minus 7 times U plus 4. Then we'll use the zero factor property. Zero factor property, you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set U minus 7 equal to 0, and I'll set U plus 4 equal to 0. And that gives us U is equal to 7, and U is equal to negative 4. Step 3. Replace U with the middle part from step 1. Remember up here in step 1, our middle part was the x plus 5. So we're going to plug in the x plus 5 for the U in both of these. Again, whatever's in the middle here is always what you plug in for U at this point. And then solve. Solve for x. Well, these are linear equations, so they're not very exciting. They ought to take the 5 over. So we got x is equal to 7 minus 5, or x is equal to 2. Here I'll take the 5 over. And we get x is equal to negative 4 minus 5, or x is equal to negative 9. And those are our answers. Let's look at our next one. X minus 6 square root of x minus 16 equal to 0. Okay, now obviously it's a U substitution because we're in this section, but if we weren't in this section, if you take your middle part, in this case it's a square root of x, again you ignore the coefficient. If you square it, see what it gives us. Well, remember when your index matches a power, in this case there is no number in this slot right here, so it's by default 2. Index of a square root is 2. If the index matches the power, they cancel each other, so that would give us x. So again, if you can take your middle part here, square it, and it gives you this first part, that's when you can use a U substitution. Step 1. Let the middle part be equal to U, so this is going to be equal to U, and the first part be equal to U squared. So this becomes U squared minus 6U minus 16 equal to 0. Step 2, solve for u. Now this is again the PST method, and factors as u minus 8 times u plus 2 equal to 0. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So we got u minus 8 equals 0, and u plus 2 equal to 0. And we got u is equal to 8, and u is equal to negative 2. Step 3. Replace u with the middle part from step 1. The middle part from step 1 was the square root of x, so we're going to plug that in for the u. Again, it's always whatever's right here, ignoring the coefficient, whatever's right here is what you plug in for u. And then we solve for x. In this case, these are radical equations. Now we got our, we're going to use radical equations to solve each one of these. And our steps for radical equations, first step for radical equations says get a radical by itself. Well, that's done. Our second step for radical equations says to raise both sides to a power equal to the index. Index is number in this little slot. There is no number there, so it's by default 2. So we're going to square both sides. So we'll square that, and we'll square the 8. And we'll do the same thing on this one. So we square the square root of x, and we square the negative 2. Well, these are going to cancel and gives us x equals 64. In this one, these cancel, gives us x, and negative 2 squared is 4. Now, if you remember radical equations, our last step is to check our answers, because you'll get the correct answer, but sometimes you get false answers. Now, you want to check them in your original equation up here. If I put 64 up here, put 64 there, it's 64. If I put 64 here, I got square root of 64, which is 8, times 6, which is 48. So I got 64 minus 48, which is 16, minus 16 equals 0. That one checks. If I put 4 up here, put 4 here, that's 4. If I put 4 here, that's square root of 4, which is 2, times 6 is 12. So I got 4 minus 12, which is negative 8, minus 16. That does not equal to 0. So this one does not check. Actually, you may have saw at this point, when we got square root of x equal to negative 2, a square root can never equal to a negative number. So that one will never check anyway. But it'll be obvious when you plug it into the original equation. Let's look at our fourth example. Got 14a to the negative 2 plus 19a to the negative 1 equals 3. Now, this one has a little bit of a twist to it. It doesn't have 0 on one side, so I can take 3 over, though. So I got 14a to the negative 2 plus 19a to the negative 1 minus 3 equal to 0. The u substitution, you do need 0 on this side. Okay, now we're assuming that our middle part here, the a to the negative 1, is going to be our u, but let's double check that. Again, if you take your middle part and you square it, let's see if it gives us our first part. Remember, when you're raising an exponent to another exponent, you multiply them together. Negative 1 times 2 gives us negative 2, which does equal to that. So it is going to check. So our first step, let the middle part, the a to the negative 1 be u. Again, that never includes a number. Then the first part, which is a to the negative 2, be u squared. So this becomes, after the u substitution, 14u squared plus 19u minus 3 equal to 0. Now step 2. We want to solve this using the key number. And let me see, factors as let me double check myself. Some key number I can do some in my head pretty easy, some I have to think about. 21u minus 2u minus 3. I'm not showing all the steps here, but I am showing the method, so you can go back later and do all the steps yourself. Okay, zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I got 7u minus 1 equal to 0, and 2u plus 3 equal to 0. And then I want to solve these. So here I'll take negative 1 over, I get 7u is equal to 1, or u is equal to 1/7. Here I'll take 3 over, and you get 2u is equal to negative 3, or u is equal to negative 3/2. Step 3, we want to plug our middle part, which is a to the negative 1, in for the u. So I got a to the negative 1 is equal to 1/7, and a to the negative 1 is equal to negative 3/2. And then we, it was a, wasn't it? I say in my steps to solve for x, I think. Yeah, solve for x, but solve for a, as the case may be. Now, first thing off is we don't want negative exponents. So we can rewrite the a to the negative 1 as a to the negative 1 over 1, like that. You can always create a fraction by putting it over 1. Now, how we get rid of negative exponents is you take them opposite of where they are in a fraction. So I'll take this a to the negative 1 here and move it down to the denominator. And I'll do the same thing over here. Move it down to the denominator. Now, it looks like there's nothing left up on top, but we'll put a 1 for the numerator. You never have something blank in a fraction. Now, when you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So it goes from an a to the negative 1 to an a to the positive 1. It goes 1/7. And then do the same here. We've got 1 over a to the first is equal to negative 3/2. Different ways you can solve this. I'm going to use a little bit of a trick here, but this is technically a rational equation, because you got an equation, got a variable in the denominator. You could also use proportions, where you got a single fraction equal to a single fraction, and cross multiply. There's another trick that if you got a single fraction equal to a single fraction, what you can do is you can flip both fractions. So we'd have a to the first over 1 is equal to 7 over 1, which gives us a is equal to 7. Over here, if I did the same thing, a to the first over 1 is equal to 2 over negative 3. Then we get a is equal to negative 2/3. And those would be our two answers. Now, I checked the answers in the previous problem, but I'm not doing it on this one. It's only when you raise both sides to a power that you have to check it. There's some other situations where you have to check it too, but in this particular problem, the only thing you'd have to worry about is that if you ended up with an answer that caused, this right here is 1 over a, and this is 1 over a squared. If you came up with something that caused a denominator to equal 0, then you'd have to exclude it. But beyond that, you do not check this particular type. Now, I'm going to check to make sure I have these pages saved. So let me see. It's kind of slow. There it goes. I guess I do have them saved. So I need to start a new page. And so let's take a look at this one. We got w to the 2/3 plus w to the 1/3 equals 2. Again, we have to have 0 on one side, so I might as well bring that over. W to 2/3 plus w to the 1/3, and bring the 2 over becomes a negative 2 equals 0. Okay, let's check this. Our middle part, w to the 1/3. Let's take it to the second power and see if it gives us our first part. When you raise an exponent to another exponent, again, you multiply them together. 1/3 times 2 gives us 2/3, which is this part right here. So it does check. It is a U substitution problem. Okay, step 1. Let the middle part be equal to U, first part be equal to U squared. So this w to the 1/3 be U, and this w to the 2/3 will be u squared. So we can rewrite this as u squared plus u minus 2 equal to 0. It'll always be in quadratic form after you get done with your u substitution. Step 2, solve for u. This is a PST. So it factors as u plus 2 times u minus 1 equal to 0. Zero factor property. You get 0 one side, you factor the other side, you set each factor equals 0. So I'll set u plus 2 equals 0 and u minus 1 equal to 0. Which gives us u is equal to negative 2 and u is equal to positive 1. Step 3. Replace u with the middle part from step 1. Well, the middle part is w to the 1/3, so I'll put w to the 1/3 in. And same thing here. And then I say solve for x, but of course this is now w, so let's solve for w. W to the 1/3. In college algebra, you'll learn how to solve when you got a rational exponent, how to solve these type. But for now, these are radicals, so I can rewrite this in this manner. And same thing over here. If you remember from when we worked with radicals, if you got it in a fractional power form, rational exponents, then whatever number is in your denominator, that's what goes in this slot. That's called your index. Whatever number is up on top is what goes right there. That's your power that goes inside. So this is basically just the cube root of w is equal to negative 2, and the cube root of w is equal to 1. Well, these are radical equations. And if you remember our steps for solving radical equations, first step was to get a radical by itself, which we have. Second step was to raise both sides to a power equal to the index. Index is numbered in a slot right here, so we're going to take both sides to the third power. Now we're applying the power principle when we do this, so we know we're going to have to check our answers once we get done, because sometimes you get false answers. Okay. When your index matches the power you're raising it to, then they cancel each other away, so that gives us w equals negative 2 to the third is negative 8. In here, again, those cancel. We get w, and 1 to the third is 1. Let's check negative 8. If I put negative 8 up here, negative 8 to the 2/3 and negative 8 to the 1/3, negative 8 to the 2/3 would give us 4. And negative 8 to the 1/3 would give us negative 2. 4 minus 2 does give us 2, so it checks. If you're not very good at checking that, you can plug it in your calculator. And the important part to remember, if I were to plug it in my calculator, is when I put the negative 8 in here, I had to put parentheses around the exponent. So I'd put negative 8 inside of parentheses, caret, beginning parentheses, 2 divided by 3, closing parentheses, to do this part. That's on a TI-3, TI-4. Now 1. If I put 1 up here, 1 to the 2/3 plus 1 to the 1/3. 1 to any power is 1. So we'd have 1 plus 1, which gives us 2. So it checks. And those are our two answers to that problem. Let's look at this one now. We've got 1 over x plus 3. This one's got a little bit of a twist to it, which is why I threw it in as examples. Plus 7 over x plus 3 equals 18. Now, imagine if I take 7 over x plus 3 to the second power. It's not going to give me this, so that's not going to work. But these look really close. 1 over x plus 3 and 7 over x plus 3. What I could do is rewrite it this way. 1 over x plus 3 squared. That's 7. I can put it out in front as the coefficient. 1 over x plus 3. Now bring the 18 to the left side, becomes a negative 18, because we know we have to have 0 on that side. Okay, now if I take the middle part, which is 1 over x plus 3, if I take it to the second power, it gives me the first year. So then it works out. So sometimes you have to do a little bit of manipulation like that. Okay, first step. Let the middle part, whatever it looks like, be u. And the first part, be u squared. So this now becomes u squared plus 7u minus 18 equal to 0. Step 2. Solve for u. This is the PSD. And seems like I factored this in this manner on an earlier problem. Maybe not. Memory's no good. Okay, zero factor property. Get 0 on one side, you factor the other side, you set each factor equal to 0. So we got u plus 9 equal to 0, and u minus 2 equal to 0. Which gives us u is equal to negative 9, and u is equal to positive 2. Step 3. Plug the middle part from step 1, which was the 1 over x plus 3, in for the u. So we got 1 over x plus 3 is equal to negative 9. And we got 1 over x plus 3 is equal to 2. A couple different ways you could work this. This is a rational equation. So you could go through those steps. And I'll actually do that in this problem. Or this is a single fraction here, and I could rewrite the negative 9 as negative 9 over 1. And I can rewrite the 2 as 2 over 1. And remember earlier we said if you have a single fraction equal to a single fraction, you can flip both fractions. So the different ways you can solve this one. I'll solve this with rational equations. Rational equation says get rid of parentheses, don't have any. And then it says get rid of fractions. And part of it is you have to factor all of your denominators, but these are fairly simple, so we don't have to do any factoring. So to get rid of the fractions, we multiply everything by the LCM of all our denominators. We only got one denominator, so that is our LCM. So we'll multiply both sides by x plus 3. So we'll take x plus 3 times 1 over x plus 3, and we'll take negative 9 times x plus 3. And same thing on this equation. We'll take x plus 3 times 1 over x plus 3, and we'll take 2 times x plus 3. Now these x plus 3 is going to cancel. So we get 1 equals negative 9 times x is negative 9x. Negative 9 times 3 is negative 27. And over here, we've got 1 left, and then 2 times x is 2x, 2 times 3 is 6. Okay, take the negative 27 over, so I got 1 plus 27 equals negative 9x. So we got 28 is equal to negative 9x. And then divide both sides by negative 9. And we get x is equal to negative 28 over 9. This one takes 6 over, so we got 1 minus 6 is equal to 2x, which gives us negative 5 is equal to 2x. Then divide both sides by 2, and we get x is equal to negative 5 halves. Those seem like weird answers. Let me just double check myself. Okay, u plus 9, u minus 2. I don't work off a script on these. I'd take the fun out of them. Plug that back in. Okay, multiply both sides by that. Yeah, sure enough. Now these originally, this is considered a rational equation because you got an equation with variables in the denominator, and we just have to make sure our answers don't cause any denominator to equal 0. The only answer that would have caused us a problem was negative 3. If I'd come up with an answer of negative 3, then negative 3 plus 3 would have gave us 0. So these two answers are fine. And I believe that was our last example.